recording here. Go ahead and write your name at the top of the paper there and what you're going to take a picture of and email to me. Now, if y'all have, any of y'all have a scanner at the house, you can just scan it and upload it that way, but it's easier just to take a picture and send it. So just put your name at the top part here. And we're going to just take some notes, and then we're going to get into some problems that are based off of these examples here, okay? So the key word here is we're going to subtract. Obviously, we're getting, come up to the top up here, and let's write down finding area of composite figures. Let me pull this back. Get this set up for you guys. This book is so big. Okay. Okay, I'm on the green book, and what page am I on? I'm on page 607. So if you want to write page 607 in the green book, you can write that. So we're finding the area of composite figures by subtracting. Okay, and so example A, we'll just draw out the shape the best we can. And we don't have a straight edge right now, so we're just going to have to go with it. All right, now this is a straight down line here. This makes a right angle. Obviously, I'm fixing to find out a base and a height here when it's separated by a right angle like that. So you're going to see a situation like this on the ACT where you're trying to find the area of this little shaded zone right in here, okay? Those of you who like woodworking or carpentry can see how you this could look like a 2x4, the end of a 2x4, and you're cutting out a section of the 2x4 for a nice, pretty maybe piece of molding or something like that. You would have to cut away some wood in order to make a design in there, right? So that's what's fixing to happen. We're going to take basically these two shapes, and we're going to just subtract a triangle from a rectangle. So you take the large shape, which is a rectangle or a quadrilateral, and then you're going to subtract off the triangle. So obviously the first thing you need to do is find the base and the height of the quadrilateral or the rectangle. All right, so I'm going to put rectangle here. And they give me that this is 36 meters. That's very long, by the way. They give me that this over here is 18 meters. That's all I need to find the area of this quadrilateral. And so I would write out, I'm going to change pens. This one's kind of thick here. All right, I'm going to change, the base is 36 and the height is 18. So 36 times 18, according to the book, is 648. 648 what? Meters squared, okay? So keep that in mind. This is the area of the big rectangle. It's not the area of the shaded part. That's coming up in just a second once I just subtract off this triangle. So if you turn this upside down, you would notice that you would have the area of a triangle, and if you'll remember, the area of a triangle's formula is base times 1/2 base times height. Now this base times height and this base times height may not be the same. Some of it might be, but it won't all be the same, not all the time. So what we're going to have is 1/2. Now what is the base of this triangle? The base of the triangle would be 36 meters. What's the height of this triangle? Well, they give it. It's right there in the middle. It's 9 meters, okay? So we've got a base of 36 and a height of 9. All right, I'm going to circle half of 36 because I know what that is. That is 18 times 9, all right? And according to the book, 18 times 9 is 162 meters squared. 162 meters squared. So now we're going to take the area of the rectangle and subtract off the area of the triangle by and see what we get. So if you'll notice, the answer here is 648 minus 162, and we get 486 total meters squared for that shaded zone right in there. So so the area of the base of the shape will be 648 minus 162, which is 486 meters squared. All right, so put a box around that to distinguish that from the rest of the problem, okay? So that's part A. We're going to do another example like that in just a minute. So draw me a line like this down the middle, and let's go look at part B this time. We've got a little bit different shape to deal with. All right, in this case, it looks like a basketball court. So we've got a rectangle, just like we did last time. And if you'll notice, there's dotted on the sides because this is not the shaded part of this is not a rectangle. It is an hourglass shape, sort of, I guess is kind of the way you look at it. So it's kind of an hourglass figure here. So I'm going to shade that zone right in there. Look, it looks kind of like a large, strange, maybe like an I, the letter I. But okay, looking and let's see if we could find out what the base and the height are. Now remember, bases and heights are separated by a right angle. Okay, so the bottom is 33 feet, and the height would be 16 feet according to this graph, this chart here. Well, if this is 16 feet in the middle, then that means this over here is 16 feet and this over here is 16 feet. Now, you need to be smart about this when you go to do this stuff, because you got to think, okay, yes, I have two areas to subtract off, but what if I put those two areas together? What would that look like? You notice how that's a semicircle and that's a semicircle, right? And they're the same size as far as the diameter is concerned. Well, if you put these together, that would make an entire circle. So we're going to say the area of the circle, all right? We're going to need the formula for the area of a circle, and we're going to need the formula for the area of a rectangle. All right, so the area of a circle's formula is pi r squared, okay? And the area of the rectangle is base times height. So what's going to happen is we're going to subtract this from this, and we're going to get our area of the shaded zone there, okay? So let's pull this down, and let's see what we can pull out of our hat here. We've got area equals base times height for the rectangle. So we have base of 33 and a height of 16. Multiply that out. We'll do that in a minute. Now I'm going to subtract off the area of a circle, which is pi r squared. Now here's the problem, because you have to know well, two things. One, what pi is. We all should know that that's 3.114 equivalent, or approximately. And then the R stands for radius. Well, radius is half of the diameter. So the radius would be 8. Okay, you see how it takes 2 8s to make a 16? Well, the radius of the circle would be from here down. That's 8. All right, so now we're going to put 8 here, and we're going to square that. So remember, we're subtracting these two things because I'm taking out the section that is dotted there on both sides. So according to the book, 33 times 16 is 528. So I'm going to put 528. That's going to be feet squared. And then we're going to subtract off the area of pi times, hold on. Okay, so make sure everybody's here. Okay. All right, so then we've got, those of you who are just joining us, I've only done two little examples so far. I'm almost through with the second example, but I'm in the textbook on page 607, finding area of composite figures by subtracting. So we're taking a shape and we're cutting out another shape from that. In this case, we have this rectangle, and we're cutting out two semicircles. which add together to make a circle. So square minus circle equals the shaded area, okay? And so that's where all this stuff here is coming out to be pi times 8 squared, which the book, according to the book, says is 64 pi. They keep it in terms of pi. So we're going to put 64 pi, and then that's going to be feet squared also. So now we subtract these two things. Okay, let me look at this. I got a message. I'm going to read this real quick. Okay, hang on. I must have to click on something just a second. 1 second. Oh, I see. There we go. Now I think we're good. Okay. I didn't know that you guys were left hanging there. So this is where we're at right now. And we're subtracting the circle from the rectangle, and I get the area of the shaded zone is going to be 528 minus 64 pi feet squared. Now they leave it in terms of pi here. That's okay to do that. Most of the time I would do that. But if I were, like actually cutting this out, if I were in the workshop taking my 2x4 here and shoving it down the planer or on a router, cutting out this little section, I would need that to be exact, pretty much. All right, because you want to know how much area your board takes up. All right, so now I'm going to draw a line here. We're going to try and keep everything nice and tidy here. So we've got the first two sections, the first two examples. Now let's go work an example problem from example 2. We're still in section 9.3. So example 2, here's another example here. So let's do, this one's pretty interesting. This is a rectangle take away a triangle. You can't see the triangle. This is a rectangle take away a circle. We just did that. Let's come over here and do this real quick. So let's find the area of this number 5. Let's go do that real quick. So I'm on page 609. So I'm going to draw this rectangle and then leave off a little shade right there. Okay. So page 609. Number 5, let's work this out. So I'm just going to draw the little shape again. It looks like a rectangle with a little sliver cut off of it like that, okay? So it has a 6, a 3, a 2, and a 5, all right? 6 meters, 3 meters, 5 meters, and 2 meters, all right? From here to there is 2 meters. Now, this little section right here, they don't have it marked off, but I'm going to go ahead and mark it off. It's no more than just a little right triangle that they cut out right there, okay? So we're going to take the big area of the rectangle, which is going to be base times height, and then we're going to subtract off the area of the triangle, which is 1/2 base times height, okay? And so you remember a base and a height are separated by a right angle. So in this case, on the right triangle, we have a right angle right here in this corner. So we have a base of 6 and a height of 3. All right. Now we have the little triangle guy in the corner down there, and they don't give us any details on that. So what do we have to do? We have to take 6, subtract away 5 to get what's left over here, and that's going to be 1 right there. So I'm going to put a 1 meter. So that's 1 meter there. Now let's look over here. So if you look at the height, we have 3 and 2. If you subtract 3 and 2, you get 1 again. So this is a 1 on each side. This would make this an isosceles triangle, okay? So we have 1 again there, okay? So now this is the rectangle. This is the little triangle. And then the shaded zone is what I need the area of, okay? So we're going to find that now, but these are all meters, okay? So we've got area equals 18 meters squared. And then this area is 1/2 of 1, which is You could put half or 0.5. It might be best just to put 0.5 here. And so your final answer will be 18 take away 0.5. Well, $18 take away 50 cents is $17.50, right? And then that's going to be meters squared, and that's the area of the shaded region, okay? So I'm blocking that off. Now you see how a little problem like this, you don't have to make it huge and take up a whole lot of space. You can fill in the blanks with what you already know, okay? So that was just a practice problem. If there's any questions on that, just type them in the chat real quick, and then if there's any questions on the rest of this that I'm pulling up here, go ahead and type them in the chat, and I'll answer anything that you send me. I see everything that pops up, so I try to catch it as soon as I see it. All right, so we're on section 9.3. We just did example 2. I'm only going to do example 3. I'm not going to do example 4. So we're going to go into a little more detail here. You might see a problem similar to this on the ACT, not necessarily exactly the same, but you're going to see a worded problem like this, and you're going to be given, remember, you're given only 1 minute to answer any question, and they tried their best to make it like 3 problems in one, just about it. So, I mean, you're going to have situations like this where you have 3 different shapes, and then you got to figure out how, within 1 minute, you know, how much area covers all this stuff, okay? Well, there's a couple of ways to handle this problem. And if you'll notice, in example 3, they're not subtracting anything, although you could think of this like a big rectangle, like we said a while ago, with the base and all of this height added together, and get that area, and then figure out what this shape is. Well, this looks like this is more than just a trapezoid. This is like a 1, 2, 3, 4, 5. That would be a pentagon. You'd have to subtract off a pentagon, all right? And there's formulas for that, but in this case, it's easier for you to take it one section at a time. So rectangle, long, trapezoid, short, and then really short rectangle, okay? So let's go through here and look at the details, and I'm just going to draw out what I see here on the sheet of paper over here. So on the left-hand side of your paper, let me pull back so we can see what we're doing here. All right, if you're going to be a landscape architect, this would be really amazing to know how to do, because you're definitely going to be charging by the square footage whenever you give somebody an estimate. Before you even start the job, you have to know how much square foot you're talking about, because if you wind up having to buy 5 extra plants or 5 extra trees, well, that comes out of your paycheck. You have lost money for the company, or either you have lost money for you, or you have lost a job as a landscape architect. So you need to know how to do this kind of stuff. In this case, we have Katie here, okay? So we're going to draw this example 3, all right? So let's see, draw this shape the best we can. All right, we got a 28.5 feet length here. Now I'm going to come straight down. This is a rectangle. This is a trapezoid. And then this is a rectangle right here, okay? And so it doesn't look like it here, but you could see visually how that would equate out to what we're drawing here, okay? So we've got, let's do only the things that I'm talking about at the moment. So we've got a base and a height like this. I'm only going to focus in on this rectangle at the top. So what would happen here? You'd have area equals base times height, right? And then base times height would be 28.5 times 7.5. All right, and we're going to find out what that is in a minute. Now I'm going to come down here to this trapezoid. A trapezoid is no more than really just a triangle with 2 bases. Okay, and how do I know that? Well, you've got a height here. See this height right there? So we've got the height according to this. This is 19.5. Okay. According to the drawing, it says that we have 19.5. And how do we know what they're saying here is 6? Well, if you take 19.5 and you subtract off over here the 7.5, and then you subtract off this 6, you'll find out that from here to here on this trapezoid is also 6, okay? So that's where that height 6 comes from. But if you'll notice, it makes 2 right angles here, right? And anytime you have a base and a height, it's separated by right angles. Well, I have 2 right angles, and one line is longer than the other line. So you can think of this as 2 different bases, okay? So this base here is 18 feet, and then this base here is 12 feet, okay? So we're gonna add, let's go back over here and off to the side, we're gonna put 1/2 times 18 plus 12. We're adding these bases together, okay? No, it doesn't make a lot of sense, but it does if you work it out mathematically. And then that equals 6. And then we're going to add these areas together. Now we've got one more area to do, which is another rectangle. That's base times height. This time we have a different base and a height. We have 12 as my base, and then what did I say? 6 right here was my height, according to what that drawing has over here. So that's 6 foot there. All right, so we're going to put 12 times 6. Now we're going to start backwards. This is 72 feet squared. The book says the second one is 90 feet squared. This is 90 feet squared. And then this one right here is 213.75 feet squared. So if you were to give an estimate on a job as a landscape architect, and you were to tell the person, okay, I charge $40 per square foot, well, that includes all the bushes and trees that you, which that would be a lot of money, by the way. That's as much as a house is, to be honest, in some cases. So let's add these together. So our total area is 213.75 plus 90 plus 72, and that turns out to be 375.75 feet. 375.75 feet squared. Now I'm noticing that there's something else added to this problem down here at the bottom. So this may not be everything I need to do. So let's go back and read the problem itself. All right. It says, Katie is using the given plan. Now this is a perfect example of an ACT problem. They want you to do this in 1 minute. I mean, really, this is not doable in 1 minute. All right, so Katie is using the given plan to convert part of her lawn to a xeriscape garden. That's a word. There's the word of the day, xeriscape. I'll have to look that one up. A newly planted xeriscape uses 17 gallons of water per square foot per year. 17 gallons of water. That's like 17 gallons of milk, right? You fill up 17 gallons of milk full of water. And then that's per square foot. Now a square foot would be just this little section right here, okay, per year. So that's a lot of water, okay. So how much water will the garden require when you're going to expect a humongous number, really not large. So how are you going to know that unless you know what the square footage is, okay? Square foot per year. Well, here we go. All right, it says the garden will use 375.75. That's the number of square footage times 17. Remember, it's 17 gallons, 17 gallons, 17 gallons. Imagine little squares of 17 gallons of water. That's how much it uses all year. Like if it didn't rain at all the whole year, if it didn't rain the whole year, then you would have to get that many gallons, 6,387 gallons of water per year, okay? So now let's move over, and now I'm gonna skip this section. I think we're okay. I'm not gonna do any more practice problems over here, although I do want you to see something here, just kind of a quick overview. If you were to take a shape like this, all right? Now, I don't want to write in my book. I don't have a pencil. But if you'll notice, you've got a kind of a triangle shape here. Like if you were to draw out a triangle here, draw out a triangle here, triangle there, triangle there. I know it's not quite exact, but I mean, it's pretty close. You got triangle, 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 triangle. Well, if you have two triangles, that makes one square. See this triangle stacked on top of that triangle there? Well, if you got two triangles, that you can equate that or approximate that to be one whole square. So let's see how many there. I can see that there's one whole square there, one whole square there. One square there, because there's two triangles. One square there, there's two more triangles. So that's 1, 2, 3, 4, all right? Then I see another triangle here, that's 5 when you put those two triangles together. And then you see another triangle here and another triangle here, 6. So it's approximately 6 square inches. You see that? All right, so I'm not going to go over that, but I just wanted you to see how you can approximate things like in real life. You're going to have jobs as a landscape architect if you do become one, where you've got somebody's yard looks like this. Well, how in the world are you going to calculate square feet if nothing is square? Well, you just count what you can, and the rest will take care of itself. Okay. You could throw in an error here and there, maybe an extra square foot just to be safe, you know. But it's just a little more detail than you need. Okay, so let's move over to section 4, 9-4, I believe, is where we need to be. Oh, yeah, okay. So we're going to go over to section 9.4, and we're going to talk about a new topic, perimeter, and well, obviously it's old topic, but perimeter and area. But this time we're going to do it in the coordinate plane, and I'm not really using the right paper for this. Okay, I really need coordinate grids to be able to do what I'm fixing to do. So I'll try and get some grid paper for tomorrow so you can see a little more accurately what we're supposed to do. But as of right now, let me pull this over here. All right, let me pull this back. So far, we've only got about 2/3 of a page full of notes. Well, I'm going to wrap up the rest of the day trying to talk about 9-4. And we're going to do area and perimeter. Clear that up. Perimeter using a coordinate grid coordinate. All right, so I'll zoom in on this, and we're going to fill in this last little bottom zone down here and then finish out the day with this one topic. Okay, trying to straighten it up the best I can. I don't know how I can do this. I'll just straighten this up. Okay, so let's look at example 1. I'm going to pull this down, and you can kind of see how this little composite figure, it's made up of a bunch of little bitty figures, okay? And if you can't see that it's made up of a bunch of little figures, you can at least see that it's made up of a bunch of little squares dealing with the coordinate system. So we're going to estimate. The key word here is estimate, okay? If there was a snake coiled all the way around in this shape like this, and then you took the snake and held him by the head and by the tail and stretched him all the way out, you could measure how long he was. That would be the perimeter, okay, of the shape. Now, and we can estimate that the best we can, but the area that he covers here would be counted in squares. So you count square, 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 square. That's area, okay? So let's go through this, and we're going to do the area right now, and then we'll talk about perimeter in just a second, okay? So it says, estimate the area of the irregular shape. Now, I cannot draw this accurately on my paper, and I'm not going to try to do that. I'm just going to write out the information here. So this comes from page 616. 616, this is example 1. If you have your green book with you, oh, and by the way, at some point we're going to need those green books back. So you may want to, when we get through here, I'll keep leaving information about where to drop them off. I'm not exactly sure where yet, but we probably just wind up having to do like a drop off at the office kind of thing, okay? Or I could drive by and pick them up at your house personally. So no, you don't want that, right? So just make sure that, I'm kidding. So let's look at this. So we've got estimate the area of a regular shape. So we're going to need to figure this out. So let's talk, there's two methods here, okay? The first method is to draw a composite figure that approximates the irregular shape to find the area of the composite figure. So you see how they block it off? This is kind of how I was doing a while ago, where they just basically take it and draw the best set of trapezoids and triangles and squares, and there's another trapezoid there. You can see it's kind of red. And you can figure out the area of all that stuff. Or you can come over here and you could just count the number of squares inside the figure, estimating half squares using this is more like what I was doing earlier, okay? So you remember how I was said right here, this might make that, let's zoom in on this a little bit more so you can see this, okay? This is more like what I was doing. I think this might be a little bit easier for some of you, but it's definitely a lot less work because, I mean, in this case, it's just counting basically. But you can see how right here, this little section makes it like kind of a triangle shape. That's why they have a little triangle figure right here. If you'll let me pull back, it's not clear. All right, this right here has a little triangle here so that you can see how they kind of estimated a triangle here and here. If you put these two triangles together, that makes one big square. So you could just say, okay, let's count all the squares that we know. And this whole line has 1, 2, 3, 4, 5, 6, 7, 8. And you keep going, 9, 10. That's a lot of work, right? So you could block off little parts and in your head, make your own composite figures. So in this case, this would be a 3 by 1, 2, 3, 4, 5, 6. 3 by 6, this would be 18 right here, right? And so, of course, you could block it off in your mind like this. All right. So there's 18 right there, and that leaves me with all of this crud right here, which is 1, 2, 3, 4, 5, and a triangle. Well, let's count the squares. So that's 5. Here's another triangle here. That's 6. There's a triangle. So every two triangles I'm going to count as 1. So these two triangles I'll count as 8. 1, 2, 3, 4, 5, 6, 7, 8. See those two triangles there? 8. So there's 18 in the middle, 8 on the side. That's 18 plus 8. So there I have 1, 2, 3, and these two make 4. So 18 plus 8 plus 4, and then 1, 2, and then we have 3.5 here because we got 2 together here, and then another half a square there. So that's 3.5. 18 plus 8 plus 4 plus 3.5. So I'm going to write that out just a second. So we got 18 plus 8 plus 4 plus 3.5 plus what's next? This little arm looks like a ghost. Kind of 1, 2, 3, 4. So 4 over there, okay, plus 4. So if we add all that together, we should get 37.5 units squared. So that's going to be 37.5 units squared, okay? Now we're going to finish up this little section here. And like I said, I can't really do this correctly without coordinate grids. So let's go over and look at how to do example 2. We'll start example 2, and then we'll finish up example 2 tomorrow. Okay. So I'm going to come down and I'm going to put example 2 down here at the bottom of my notes. My notes so far should look like this. So if you're behind, you might could freeze frame that screen on your YouTube video, or you can't do it if you're live with me on Zoom, but you know. You could wait and look at that YouTube video if you missed anything, and pause it at that point, okay? And I'll put the link on our Microsoft Teams, okay? All right, so here at the bottom, here at the bottom of the notes, I want to work this problem here, example 2. So we're going to find perimeter and area of this situation here. So perimeter is the distance around the shape, and area is the number of squares. You can estimate that like we did just a second ago, but sometimes your shapes get too big, right? To actually count all those squares, it's too much trouble. So we're going to use math the best we can. We're going to talk about things called vertices. Now remember, if you were to pick this up, like if you were to pick this shape up right here, where would it be, like if you were to touch it, where would it be pointy? Where would it hurt if you touched it? Where would it be sharp? It would be sharp on the corners there, right? So we've got 1, 2, 3, 4 sharp corners. That's called vertices, okay? And those vertices come to a sharp point. -4, 1, and then B is 2, 4, C is 4, 0, and then D is -2, -3. And then we're going to find the perimeter and the area of the polygon. Well, if you turn this sideways, you can actually kind of see how we're going to find this possibly could make a right angle here. And you could see how we could get base and height. All right. So we have less than a minute to finish up. And what we're going to do, I'm just going to hit the high points here. We're going to talk about vertices, and we're going to talk about slopes tomorrow. Okay. So in this case right here, we can't draw the polygon. It's already drawn. I don't have my coordinate paper here. But ABCD appears to be a rectangle. To verify this, use the slopes to show. So we're going to find the slopes and see if anything's perpendicular. Perpendicular means your slopes are, we'll talk about that, opposite reciprocals of one another. All right, y'all have a good day, and we'll see you tomorrow.